How to convert a hexadecimal number to a decimal number. In this tutorial, we will describe how to convert a hexadecimal number to a decimal number. For example, let us convert the following. Alright, we're going to convert a hexadecimal number to a decimal number. For this example, we're going to use the hexadecimal value 2EF. And we're going to show that it equals 751 in the decimal system. So let's start. Alright, so what we want to show is that for 2EF, we just want to break it down. So we'll start off with the position of the digits. For example, for F, it sits in the 0th position. E sits in the 1st position. And 2 sits in the 2nd position. And we have to keep in mind that we're dealing with hexadecimal numbers, so that means we're dealing with the base 16. So what we do is, to convert 2EF, let's start breaking down each digit. So we have, start off to the left here. So we know that 2 sits in the 2nd position. So we're going to take 2 times 16 to the 2nd power. And by saying to the 2nd power, that represents the 2nd position for the base 16. So the next position we have the value E, and because it's in the 1st position, we have 16 to the 1st power. Next we have the value F, and because it sits in the 0th position, we multiply it times 16 to the 0th power. Let's break it down further. So we say we have 2 times 16 to the 2nd power. That's a value of 256. And then next we have the letter E. One thing we need to show before we continue this is that we're dealing with hexadecimal values. Usually we have the digits. You got 1, 2, 3, 4, 5, 6, 7, 8, and 9. What this is represent the first 10 digits, and because we're dealing with hexadecimal, there's 16 digits. So this represents 10, so that's telling us we have some more. So we have A, we have B, C, D, E, and F. And so the letter A represents the value 10. The value B represents the value 11. C represents 12. And D represents 13. E is 14. And of course F is 15. Alright, so by showing that we want to take E, we said that E here is representing the value 14. So we have 14 times 16 to the 1st power. And we have the value F, which we said is 15, times 16 to the 0th power. So let's continue. So we have 2 times, let's see here, 2 times 256. Of course we have 14 times 16, and we have 15 times 1, because anything to the 0th power is 1. Alright, so 256 times 2, so it's a value of 512. So 512 represents this group here. Then the next we have 14 times 16. It's a value of 224. And of course 15 times 1 is 15. And so you add it up, we have 512 plus 224 and plus 15 does indeed comes to be the value 751. And of course that represents decimal, and this is what we wanted to show. Next, let us perform another hexadecimal to decimal conversion. This time we will convert numbers with a decimal point. Okay, we want to convert another hexadecimal to decimal. For this example, we want to convert the hexadecimal value E3D.3. We want to show that it equals 58,333.1875. Before we begin the computation, let's look at a couple of items towards the right. We have 16 to the minus 1 power is 0.0625. 16 to the 0th power is 1. 16 to the first power is 16. 16 to the second power is 256. 16 to the third power is 4,096. And also, it will become handy again. Let's do like we did previously. We showed that, so we had 0 through 9 represents the first 10 digits. And then we also say that the letter A, the letter B, C, D, E, and F. A represented 10, B represented 11, C is 12, D is 13, E is 14, and of course F is 15. All right, so let's compute. So once again, we have the value E3DD.3. And first thing you want to do is start looking at what positions that the digits fall under. So the 3 falls under the minus 1 position. The first D is in the 0th position. The second is in the first. The 3 is in the second position. And the E is in the third position. So we compute this out. We know we're dealing with the hexadecimal number system, so we want to have multiples of 16. So in this case, we start off, we have E times 16 to the third power, because that's saying that that value E is sitting in position 3. Okay, we have the next one is 3 times 16 to the second power, because it says that 3 is sitting in the second position. Then the first D, we have D times 16 to the first power, because it says that D is sitting in the first position here. Keep adding. We have D times 16 to the 0th power, because D is sitting in the 0th position. And we have one more final digit. We have 3 times 16 to the first or minus 1 position. And because that 3 is sitting to the first position to the right of the decimal point. So let's continue. So we said, now we look at what we have over here. We said E represents 14. So 14 times, and we said that 16 to the third power is 4,096. So let's represent that here. And we have 3 times 16 to the second power. We said 16 to the second power is 256. Next, we said that D represents the value 13. So 13 times 16 to the first power is 16. Then the next, we said D is also 13 times 16 to the 0th power, which anything to the 0th power is the value 1. Next, we have 3 times 16 to the minus 1 power, and we indicated that up here to the top, that that value is 0.0625. So continue, let's continue. Let's see. So we have the value 4,096 times 14, and it comes out to be a value of 57,344. And next we have 256 times 3, which is a value 768. Next we have 13 times 16, which is a value of 208. Next we have 13 times 1, which is 13. And then we're going to take the value 0.0625 times 3. And indeed, this comes out to be the value 0.1875. So when we add it up, it does come out to be the value 58,333.1875. And of course, this is in the decimal system. And this is what we wanted to show. This puts us in a position for my next tutorial where we describe how to convert from hexadecimal numbers to binary numbers. I hope this tutorial was helpful. If you find this tutorial to be helpful, please subscribe to my YouTube channel. Also feel free to join us here at the Computing Sector. There will be more videos and tutorials coming soon. Thanks.